Hello, welcome to this video lecture presentation on parentheses doesn't always imply multiplication and when you could drop the parentheses. So here I have two examples for you. The quantity minus 3x squared plus 2x plus 9 minus x squared plus 5x minus 4. So students may get mistaken in the fact that you see two sets of parentheses. They may be inclined to want to multiply them. However, this is not a multiplication problem, all because of this minus sign right in between the two sets of parentheses. So what we're going to have to do is get rid of the parentheses if we have to do any operations um, by distribution, and then we just combine like terms. Now let's look at the first set of parentheses. There's nothing in front of here that would change anything that's inside. We could assume there's a plus on the outside here. That does nothing to whatever's inside the parentheses. There are only a couple things that will change the value somehow that's inside the parentheses. One is if you have a minus sign in front of the parentheses, or a minus sign and a number in front, or just a number in front, because a number in front will scale up all of these, all the values within parentheses. But if there's only a plus in front or an assumed positive, you just drop it. You don't have to have it. Now, this minus sign has to get distributed by multiplication to everything inside, and all that does is just switches the signs. This x squared is assumed to be positive. So by distributing a minus, it becomes a minus x squared minus 5x plus 4. So now you have a big long string of values that we could look to see what's common. Remember, there's two conditions that have to exist to combine like terms through addition and subtraction. That is, the letters have to match exactly, and the exponent on the letters have to match exactly. Or if you have patterns of letters, everything has to match. So here we have a 3x squared, a minus x squared. So we could assume there's a 1 in front. They're like terms, so you take the coefficients, also known as the numbers in front of the letters. Minus 3 minus 1 is minus 4. You keep the x squared. Then I have plus 2x minus 5x, which gives me minus 3x. And then plus 9 plus 4 is plus 13. And that's how you go about solving a problem just like that. Now we have another similar problem down below. I recommend you pause it at this time, see if you could follow the instruction that we just went over to see if you can apply it to this problem. Once you solve it and get an answer, hit the play button, and we'll see if our answers match up. Okay, let's see how you did. So here, there's no sign in front of the parentheses. This is not a multiplication problem because of this plus sign and this minus sign. There's an assumed plus sign in front of here. We said pluses, we could just drop the parentheses because there's nothing to change them. So we'll use, with the first set of parentheses, x squared minus 4x plus 7. And then here we could drop the second set of parentheses, plus 3x squared minus 9. Now we have a minus sign. We just can't automatically drop the parentheses without distributing the minus sign first. So it's minus x squared plus 4x minus 7. So here you can see x squared minus x squared will cancel to 0. Minus 4x plus 4x will cancel to 0. Plus 7 minus 7 will cancel to 0. So we're just left with 3x squared minus 9 as our final answer. And that concludes our discussion about parentheses, that they don't always imply multiplication. If there's plus and minus signs in between them, then it's just going to turn out being a combining like terms through addition and subtraction problem. If there's a plus sign or an assumed plus sign in front of the set of parentheses, you could just automatically drop the parentheses without doing any math. The only time that you can't just drop the parentheses is if there's a minus sign and or a number in front of the parentheses that you have to distribute to everything inside by multiplication. Thank you for listening. I hope you found this useful. Thank you and have a good day. Bye-bye.